Okay, now let's take a look at graphing a rational function. So if we want to graph a rational function, we need to apply all those things that we've talked about so far. So first of all, let's talk about the horizontal asymptote. So if we look at this one, for example, x squared plus x minus 12 divided by x squared minus 4, my two degrees of my numerator and denominator are equal, which means that I take the coefficient of both of those, which are 1 and 1. So my horizontal asymptote is at y equals 1. If I factor it, like I've done here, I see that nothing crosses out, and so my vertical asymptotes would be at -2 and +2. So, and I would also, I have my horizontal asymptote, and you can draw it here. So I have my horizontal asymptote at at y equals 1. So at 1, and it should be a dotted line. I'm sorry. Oops. Let me start over. Let's do a dotted line. Of course, my line is not straight. I apologize. And then my vertical asymptotes are x equals -2 and x equals 2. So let's say this is 1, 2, 3, 1, 2, 3, 4. So at 2 and -2. Okay. And then it says that let's do our x-intercepts. So our x-intercepts, we set these equal to 0. They're going to be at -4 and 3. So -4 and 3. And my y-intercept will be when I plug in my zeros. And so when I plug in my zeros, I get 4 times -3 divided by 2 times -2, which gives me -12 over -4, which gives me +3. So my y-intercept will be at 3. So let's say this is 1, 2, 3. So I have an intercept there. Okay? And then of course I'm going to have to, plug in some more points. Or I can use my handy dandy free graphing calculator at www.desmos.com. So let's pull that up. So I'm going to say y equals x squared plus x minus 12 divided by x squared minus 4. And there, and I can actually put in my all those points that you saw earlier, but this is what my graph looks like. And I can put in my vertical asymptotes. We'll put in x equals 2 and x equals 2. And I can put in my let's see, my horizontal asymptote was y equals 1. And so those are those extra points that I have. And I see my intercepts here at -4 and 3. And my y-intercept here at 0, 3. Alright, so now let's take a look at the got it. Let's see if we can do it on our own. So let me erase this. I have y equals x plus 3 over x squared minus 6x plus 5. I definitely need to factor this. So I'm going to get x minus 5 and x minus 1. And so my vertical asymptotes are going to be at x equals 5 and x equals 1. My X-intercept will be at x equals -3 because I set this equal to 0. My horizontal asymptote, so this is my vertical, and my horizontal asymptote, my here I have an invisible 1, so 1 is less than 2, and so that means that the horizontal asymptote, we can go back here to remind us when m is less than y equals 0. So we have y equals 0 is my horizontal asymptote. My y-intercept, if I plug in zeros for all of these things, I get 3 over -5. Alright, so we're going to plug it in and see what we get here. So let me start us over from scratch. So I have y equals, put in my parentheses, x plus 3 divided by x squared minus 6x plus 5. Okay, so that looks about right. Let's see what we had here. We have our x equals 5 and x equals 1 for our vertical asymptote. So let's put that in there. It's 5. There we go. And that looks perfect. And then our y equals 0 was our horizontal asymptote. Let's see, what else did we find? We found our x-intercept at x equals 3. So let's see. Well, this is our y, and I'm sorry about that. That's not the one that I'm looking for, but we did find that one also. That's 0.6. And what did we find it to be? That was our y, and the 3 over 5. Negative 3 over 5 is 0.6. We can put in our calculator to verify. 0.6, so that's a negative 0.6 that we found. I mean, no, positive 0.6. Did I find negative? I must have a mistake in my calculation. Yes, because this is a negative times a negative, so that makes that a positive. I apologize for that. And then my, so that was my y. My x-intercept we found to be -3. Oops, sorry about that. So let's see here, and there indeed it is at -3. So I hope that this helps.